Hello everyone, welcome back to my channel. Today we will learn about types of sets. The first type of set is finite sets and infinite sets. Together we will learn because they are having a connection between the two. Now what is finite set? From the name itself you can understand that finite sets are those sets which will be having finite number of elements, and infinite sets will be those which will be having infinite number of elements. That means whose elements cannot be estimated. For example, if I'm taking this set capital X as 1, 2, 3, 4, 5, look over here, you can count the elements. Therefore, it is considered as a finite set. And another set, suppose set Y equal to number of animals in India, is an infinite set. Why it is an infinite set? Because there is an approximate number of animals in India and the actual value it cannot be expressed as a number because it's very large. So therefore we can consider it as an infinite set because we cannot count the number of animals. So therefore it will be considered as an infinite set. Now you can give another example of infinite set, like if I'm telling set of natural numbers, set of natural numbers, and you know natural number is represented as capital N, so it will be 1, 2, 3, 4, dot. We are not aware of what is the last element of the set. Henceforth, as because we don't know the end number of the set, therefore it can be considered as an infinite set. Next we will learn about equal sets and equivalent set. Like the previous one, these two are having a close connection between the two. I'll show you with example. First we will learn about equal sets. Look over here, I have given two sets over here. Capital A, the set elements are 1, 2, 3, 4, and capital B, the elements are 2, 3, 4, 1. If you closely look into the two sets, you will get some things in common between them. Now what are they? Now they are called equal sets. Now why will they be called as equal sets? Because they are having the same number of elements. Same elements. First, same elements. Look, 1, 2, 3, 4 is there in the first set, and 2, 3, 4, 1 are the same elements in the second set as well. Orders have changed. See, 1, 2, 3, 4, 2, 3, 4, 1. As I said in the previous video that when you consider the properties of the set, the orders don't matter when you are writing a set. So here the orders are different. Look, the two sets are having different orders, but they are having same number of elements. Here also what are the total number of elements is 4. Here also total elements is 4. As because these three conditions are satisfied, we will say A is equal to B, or they will be considered as equal sets. Next, coming to equivalent sets. Again, I'll take two examples, two sets. Capital A, I have taken 1, 2, 3, 4, and capital B, I have taken 5, 1, 8, 6. Then A is not equal to B. Obviously, they will not be equal sets. Why? Look, they are not having same elements. Also, their orders may have changed, but they are no question of same elements. Also, they are not of same number of elements. So therefore, what we can say that for these reasons they are not equal sets, but they are equivalent sets. Why? Because they are having same number of elements. The number of elements are same. Look, in set A also they are having 4 elements. In both the sets they are having how many elements? 4 elements. As because in each set they are each is having 4 elements, so therefore they will be called as an equivalent set. So when you consider equal sets, these three conditions should be present in the two sets, and when you are talking about equivalent set, only if the two sets are having, or if two or more sets are having same number of elements, we will say that the sets are equivalent sets. Next, we will learn about a new type of set, that is null set or empty set or void set. Actually, this set can be named by any of the one of the names. And next, we will learn about singleton set, as because they are having a close connection. So therefore, we will learn this together. Then you can easily find out the difference between the two. There is a clear difference between the two. Now, what is null set or empty set or void set? Suppose any set capital A, you are seeing that this is the only element present in the set. That means only two curly braces are given, rest no elements are there written in between the braces. Or suppose capital A is written as equals to phi. This is a Greek word whose pronunciation is phi, P-H-I. Look here, I have written P-H-I, phi. The sign is this, phi. So if any of the two names it's written, you can easily understand from the name itself that this is a condition or this is an example of empty set or null set or void set. So you can easily understand that the set with no elements or null elements will be called an empty set. It is also called null or void set, and it is denoted as by this two, only these two braces will be there. For example, now one example I have given, that X such that, it's a mathematical form or the set builder form it's written. X is a number of students studying in class 6 and class 7. Now tell me one thing, can a student at the same time study in two classes? It's not possible. So therefore this is an empty set because no such students are present who will be studying at a time in two different classes. So since we know a student cannot learn simultaneously on two classes, therefore it is an empty set. So it's an example. Next we will learn about singleton set. As I said, there is a close difference between the two. That's why I have clubbed the different sets in this way. The previous two had a close difference between the two. Then the first two had a close difference between the two. That's why I have clubbed the types of sets in this way. Singleton set means from the word itself you can understand that there is only single element or one element present in the set. Only then it will be called as a singleton set. Like for example, in second bracket, suppose any one element is written 4. Or suppose it's written 7. Any one element. So therefore it will be called as an singleton set. Now here I come to the most interesting type of sets. First we will start with subset, then we will come to superset and then power set, one up by one. First coming to subset. As you can see, subset has these two notations. Either you can put the first notation or you can put the second notation. Now what is subset? For example, I have taken one example and then I have shown. Now capital A is equals to, I have taken the set as 1, 2. That means A is a set which is having two elements and that is 1, 2. As because capital A is the name of the set, so I can call it as the father of the set because 1, 2 are the elements of the set. If I am telling you that in my home there are 4 members, then my entire home is the father of the set, father of the entire family, I can tell, because under that roof we all are staying. So therefore from that perspective I have named capital A as the father of the set, father set. Now what will be the subsets of A? What will be the subsets of capital A? Now 1, 2, how many elements are there? 2 elements are there. So what will be the subsets? First and foremost, the rule is that separately the elements will be coming out and then the combination of the elements will be coming out. And at last you have to write phi because empty set or void set is always a subset of each and every set. Okay, so what will be the subsets in this case? 1 and 2 separately has come out. Then 1, 2 there is only one combination will be present over here as because there are only 2 elements, not more than that. And phi is the Phi is the, as I said, null set is subset of every set. So phi also has to be written. So all total, how many subsets we have got? 4 subsets we have got. Now there is a formula in this respect. How to find out subset of any set? 2 to the power of n. The formula is 2 to the power of n. What is n? N is the number of elements of that particular set. In this set, how many elements are there? 2 elements are there. So in the first example, it will be 2 square, that is equal to 4. That means 4 subsets will be there of the set capital A. Did you get 4 subsets? Just check. 1, 2, 3 and 4. Yes, you have got 4 subsets. So your answer is correct. Coming to the second example, I have taken 3 elements in the set. Capital B is equals to 1, 2, 3. Now 2 cube. Now what will be in this case? 2 cube. 2 cube will be equals to 8. So what will be the subsets of B? Subsets of B, first what did I say? That the single elements will come out, then the combination of the elements will come out, and at last 5 will come out. So take out the elements 1, 2, 3. Then first 2 elements combination can be done, 1, 2, then 2, 3, then 1, 3. And then the entire set, that is 1, 2, 3. In the previous one also I have done the combination of the entire set only. Okay, so 1, 2, 3. At last the entire set has to be written. And then comma 5. So how many elements did you get over here? 1, 2, 3, 4, 5, 6, 7, 8. Look over here. How many elements did you get? 2 cube, that is equals to 8. So in this way you will find out the subsets of any set. So therefore these subsets can be called as the sons of the set, because if I am telling the original set as the father set, then obviously the elements which I am getting can be called as the sons. Like the members of a family, all who are staying under the same roof, they can be called the children of the entire home. So from that respect, I have named the main set as the father set and the subsets as the sons. They are not called actually, but just for making your understanding clear, I have renamed them in this way. Now coming to superset, second one, superset. It's just the opposite of subset. If I tell, now look over here, now from this respect of subset, I can tell that if I am taking one element 1, then I can tell that 1 is a subset. If I am taking the second example, 1 is a subset of B. From here, from this example, I can tell that this first subset 1 can be individually called subset of B, 2 can be called subset of B, 3 can be called subset of B, again 1, 2 subset of B, 2, 3 subset of B, 1, 3 subset of B, 1, 2, 3 subset of B, and 5 will also be called as the subset of B. If 1 is subset of B, then superset will be, then the main set or the father set B will be called the superset of 1. It is just the opposite of subset. If any set is a subset of the main set, then the main set will be the superset of that subset. Okay? So B is superset of 1, 2, 3, all the subsets, whichever we have got, it is superset of individual, all the subsets. So look over here, subset is all about father. Yes or sorry, subset is all about son. Subset is all about son. Yes, because we are talking about the sons over here, and superset will be the all about father. Now we know that father is always greater than son. Yes or no? By age we know that subset is all about son and superset is all about father. Father is always greater than son, right? So we will always say that superset is always greater than subset. Always remember this. Superset is always greater than subset. Always remember this. Coming to the third part, that is power set. Now what is power set? Now from this part you have understood that these are all the subsets of B or these are all the subsets of A. Now if all the subsets of B, first and foremost, if you write all the subsets of B, and then if you put curly braces in the beginning and in the end as I have written, then it will be called power set. That means now we know that one thing you must be knowing by now, that if I tell 1 comma 2 comma 3, it will not make a set. The moment I put the brackets, it will be called a set. Okay, so over here in the case of power set, just I am writing the subsets first, 1 2 3 1 2 2 3 1 3 1 2 3 comma 5, and just put two brackets at the beginning as well as in the end. Then it will again form a set, and it is set of what? It is set of subsets, because the middle part are all the subsets. So set of subsets, that means from the name itself you can understand power set means it's very powerful set. So therefore set of subsets. If all the elements of the subset are put inside the bracket, it will be called a power set. Okay, so if all the elements of the subset are put inside the bracket, it will be called a power set. So superset, subset and power set. I hope the connection is very clear. If you have any doubt regarding this part and also the other parts, please feel free to write in the comment section. Coming to the next part, that is universal set. Universal set, from the name you can understand, it's all about universe. That means the universe consists of all the things of the universe. Galaxy and planets and all are all a part of universe. So obviously you can understand it's an entire thing. So universal set is set of all elements or members related of all related sets. It is represented as E or U. That means it is such a set which will contain the elements of all the sets which are related to that set. Let's come to an example, then you can understand. Here I have taken 3 sets, 2, 4, 6, 1, 3, 7, 9, 11 and 4, 8, 11. Now what is universal set of these 3 sets A, B, C? Universal set will be such a set which will contain all these elements. Now look, if I am taking the universal set U as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 12 if I am taking, look, A is contained in this universal set 2, 4, 6. B is contained in this universal set 1, 3, 7, 9, 11. And C is also contained 4, 8 and 11. So all the 3 sets are contained in that universal set. So in this case, this A, B and C are the related sets. So universal set is such a set which will contain all the elements of the related sets. That means the sets which are related at that point of time to that universal set. It is the main set. Next, I am coming to the next type of set, and that is called disjoint set. From the name itself you can understand disjoint means there will be no joint in between the sets. That is what is called disjoint. So no joint means what? There will be having no common element between the pair of sets. Such type of sets will be called disjoint sets. For example, set A equal to 2, 3 and set B I am taking 4, 5. They are called disjoint sets. Why? Because 2 and 3, 4, 5, is there any element common between them? No connection. So they are called disjoint set. But if I am taking C equal to 3, 4, 5 and 3, 6, 7 is equals to D. I am naming this set as D set. These two sets if I am taking, and if I am telling that, just tell me whether they are disjoint or not. See, 3, 4, 5 and 3, 6, 7. 3 is common in both the sets. Yes, 3 is common. This 3 is common in both the sets. So therefore we can tell that they are not disjoint sets because 3 is common between the two sets. Next, coming to the next type of sets, that is overlapping or intersecting sets. Overlapping means what? That the two sets will overlap. That means one set will be having some elements which will be in common with the other set. Overlapping means what? That is what is overlapping. Okay. So two sets are said to be overlapping if they have one element, at least one element. That means there can be more than one element in common, but there has to be one element in common. If I am taking capital A as ABCD, capital B as AEIOU, what is the first element? A. And A is common between both of them. Any other elements are common? No. But we have got at least one element common. So therefore they will be called overlapping sets.